Hey folks, welcome back. Thanks for joining me again. We're going to get started on our next section, which is going to discuss internet gateways, route tables, and networking security. So let's go ahead and get started. So the first thing we're going to do is take a look at an internet gateway. An internet gateway, the simplified definition, is that it's a combination of hardware and software that provides your private network with a route to the outside world, meaning the internet. AWS's definition is that an internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between instances in your VPC and the internet. It therefore imposes no availability risk or bandwidth constraints on your network traffic. So let's pause right there for a minute and break down exactly what this AWS definition is telling us. First, it tells us it's redundant and highly available, meaning that if it were to experience some type of a hardware or software failure, that the internet gateway would continue to function. The internet gateway's purpose is to allow our instances or our resources within our VPC to be able to communicate with resources on the internet. So if we were setting up a web server on our EC2 instance, the traffic from our users would cross the internet gateway into our VPC in order to access the web server. There's also mention here of bandwidth constraints. The internet gateway does not have any type of bandwidth constraints on it, meaning that it won't be a bottleneck for traffic going into and out of your VPC to and from the internet. So it means that your internet gateway is not going to slow down your traffic as it tries to cross back and forth to and from the internet. Your default VPC already has an internet gateway attached. So we took a look in the last lesson at the default VPC. So let's go ahead and go in here to internet gateways. And you can see there's an internet gateway here. If we expand the name of this internet gateway, notice that the VPC that it's associated with ends in 5386E. So if we go up here to our VPCs, our default VPC ends in 5386E. So you can see that the internet gateway is attached to the default VPC. So let's go ahead and now take a look at this diagram that demonstrates a little bit for you how the internet gateway works or where it resides. So here's our VPC, and we provisioned, if you remember, an EC2 instance inside of a subnet. That traffic for that EC2 instance has to go through the route table, which we'll talk about in just a few minutes, but it goes through the route table through the internet gateway off to the internet. So the internet gateway is the path that allows our traffic to cross into and out of our VPC and off to the internet. Now, if we were to detach the internet gateway, then we would no longer be able to communicate with resources that were on the internet. So as you can see right now, if we go back to internet gateways here, that our internet gateway shows that it's attached. So if I were to go to actions and detach from our VPC, notice that it's telling me that I have a public IP address on an instance. That's this instance that we provisioned in the previous lesson. It's telling me that I need to get rid of that public IP address before I can detach this internet gateway. It's actually trying to protect me from being in this scenario where if I were trying to access the internet where I couldn't do so because my internet gateway is actually detached. So I'm going to go ahead and hit cancel there and click next. And then you can reattach your internet gateway. And again, by it being attached, that gives you that ability to communicate with the internet. Now, know that you can only have one internet gateway attached to a VPC at any one time. You can have them in your AWS account, but only one can be attached to each VPC. All right, so I'm going to go ahead now and click next. So now let's talk about route tables. the AWS definition is simple enough. A route table contains a set of rules called routes that are used to determine where network traffic is directed. So think of the route table as the GPS of the VPC. It directs the traffic to its destination. So when we look at our default VPC, it has what's called a main route table associated with it. So I'm going to go over here to route tables, and then notice here that it says main. So this is actually what's letting us know that this is the route table that's associated with the default VPC. So let's go ahead and click next. So now let's look at the scenario where we have multiple subnets. So we have subnet A and subnet B, and we have an instance in each subnet. And we want these instances to be able to communicate with each other. Well, when you create a VPC, there's a default route table, just like this one, that automatically has a rule in it that says that anything within the VPC automatically can communicate with anything else in the VPC. So if I click on routes, notice here that there is a route 172.31.0.0. Remember, that's the IP address range that's associated with our VPC. So there is already a local route that says that anything in one subnet can talk to anything else in another subnet that is inside of this same VPC. The route table automatically allows that. Now, anytime you see a rule that has 0.0.0.0/0, that means that's the default route. First rule says, hey, the resources that are in our VPC can talk to other resources in the VPC. The second rule says, if that traffic is not local for the VPC, then go ahead and automatically send it across the internet gateway out to the internet. Anytime you see this rule and you see IGW, that's saying direct that traffic or all remaining traffic or any remaining traffic to our internet gateway. And anything that you see that has local next to it means that it's allowing the traffic to route locally within that VPC. Now, the route table points to the internet gateway. So if you detach the internet gateway, the route table still continues to point to it, but you won't have any internet connectivity because the internet gateway is detached. So here it shows us our internet gateway. This is an active route, but if we go to our internet gateway settings, we need to look here and see if it shows attached. If it shows attached, then we should be able to communicate out to the internet. If it's detached, then we no longer have the ability to communicate with the internet. Let's look at a scenario where we actually attach a new internet gateway, which we can do. We first have to detach the existing internet gateway, but then we can attach a new one to the VPC. So again, this goes back to the fact that we can only have one internet gateway attached at a time to the VPC. All right, so when we think about networking security, this is what controls the ability for devices to be able to communicate with each other. So a network access control list, or a NACL, is basically a firewall or a security layer that sits in front of your subnet. Now, what exactly does it do? Think about a bouncer meaning someone who sits at a club or at a party place and determines who is allowed in and who gets rejected, right? So who's allowed and who's rejected. That's what the NACL is doing. You knock on the door and say, hey, I want to come into this party. The bouncer says, you know what? I don't know who you are. You're not allowed in here. Or, you know what? I'm looking at the list and your name is not on it, so you're not allowed in here. Okay, so that's what a NACL is doing. It's specifically saying you can come in and you're blocked. Now, your network access control list actually functions in a couple of different ways, in a couple of different directions, inbound and outbound. We're going to talk more about how those network access control lists work in another lesson. But for now, just understand that that's what the network access control list job is. It's the bouncer at the door, or the doorman, if you want to call him a doorman, who basically says you're accepted, you're rejected. And that's exactly what a firewall does. A firewall can be either hardware or software, and it determines what type of internet traffic to allow in and what to block. So an example here is if we wanted to allow HTTP web traffic. So HTTP would be like the type of traffic that allows you to access a website, and you wanted to allow HTTP into the subnet, then HTTP would knock on the door and the NACL would say, hey, I know you, you're HTTP. You're allowed to come in. So HTTP would then be allowed to come into the subnet level. And then what if we had FTP traffic? FTP is a file transfer protocol. It allows you to copy data or move data from one location to another. As an example, when you build a website, you need to put the files for your website up on a server. You would use FTP to transfer those files up to the web server. So the NACL could say, hey, HTTP, you're allowed through, but then it could say, you know what, FTP, I'm looking at the list and your name is not on the list. So I'm sorry, but I'm going to have to reject you. I'm going to have to block you from being able to send your traffic into the subnet. Security groups is also another type of firewall. The security group applies more so at the instance layer or at the network adapter for the instance. This allows us to say if we have multiple instances within the same subnet that actually need different levels of access, where that communication might be allowed in through the NACL, but it's not allowed in through the security group. So it's like having two sets of doors. So think about if you go into an event hall for a party, there might be one door that you go into, and then inside of that event hall, there may be multiple rooms where different activities are happening. A conference center is a great example of that. You go into the main conference center, you're first checked to see if you're allowed entry into that conference center. Once you're in the conference center, you try to go to, say, an individual lecture. Once you go to that room, then there's another list where they check to see if your name is on that list. Well, that's exactly what network access control lists and security groups are doing. So this diagram is actually representing that setup for us. So notice that we have these subnets that we want to allow and deny specific types of traffic into these subnets. So notice here that our NACL says, hey, this communication is allowed into this subnet, but into this other subnet, that type of traffic is actually denied. So this could be, hey, HTTP traffic is allowed into this subnet, but when it tries to go HTTP traffic into this subnet, then a deny is actually received as a result, because the NACL says if you're accessing subnet B for HTTP, sorry, can't let you in. But if you're going to subnet A for HTTP, thumbs up, you're allowed to go in. So we're going to talk a lot more about NACLs and security groups as we continue to go on to the next lesson. But for now, that gives you kind of some insight into how all of these components, the internet gateway, the route table, the network access control list, and the security groups, how they're directing or allowing traffic to flow from our EC2 instances all the way up through to the internet. So thanks again for joining me. I'll see you in the next lesson.